Friends, now I'll talk about access port and trunk port configuration. This is a small lab which is set up. I'll configure it and then we'll show you how to configure access port, trunk port, and in the trunk how to do ISL encapsulation, .1q encapsulation, verification of the commands, and we'll do a lot of things while doing the lab. Okay, so let me show you the task list which I have for you. I'll configure two VLANs on switches, we'll name those, and we'll configure access VLANs on ports which are connected to routers. We'll configure trunks with ISL with .1q after that, and we'll show you how to check the trunk and allowed VLAN on that interface. We'll do a ping test. So ideally we will be making changes in four things. First of all, creation of VLANs, then access port configuration, then trunks with ISL, and after that .1q. So four changes we'll be making. So what is access port? The port which is tagged with a single VLAN is known as access port. So if you want to tag a port with multiple VLAN, then you need to make it a trunk port. So let me take you to diagram and we'll show you. Let's say that you have a workstation connected here, let's say PC1, and here PC2, and you have configured access port, this port as an access port in VLAN 5, and similarly this port as access port with VLAN 5. So when PC1 will generate traffic, it will enter switch 1, it will be tagged with VLAN 5 because this is the configuration, right? So once it will leave after processing of the data frame, the switch 1 will untag it. It will remove the tag of VLAN 5. That's how it happens. Let me re-show it. When PC1 will send packet towards switch for PC2, it will tag the traffic with VLAN 5, and once it leaves the switch, it will untag it. -5 means it will remove it. So that's how the communication happens. But now the thing will change when there's a further switch connected. Let's say there is a one more switch 2, and there is a PC2 here, okay, and PC1 is connected here. So PC1 wants to send packets to PC2. This one is access port, okay, and this one is trunk port, that the link between switch 1 and switch 2. This is trunk port. Alright, so when packet will enter switch 1, it will be tagged with VLAN 5. Okay, let me change the color here so that you understand it well. So when the packet will enter from PC1 towards switch 1, it will be tagged with VLAN 5. But when it will travel over the trunk link, it will not be untagged. Remember, it will be encapsulated. Okay, so there are two encapsulations. One is ISL, one is .1q, 802.1q, also written as DOT1 small q. This is the standard. So now I'll talk about the differences between ISL and .1q in terms of frame size and other differences. ISL is Cisco proprietary, .1q is open standard. Okay, this is the first difference. Second is that ISL encapsulates the Ethernet frame with 26 byte of header plus 4 byte of trailer, but .1q, it just inserts 4 byte. Alright, so frame size is by default 1518. Okay, and IEEE, which is the organization, it says that you can add 4 bytes and make it 1522 provided it is a tagged frame. So a port MTU is set to 15, means port will allow 1522 bytes of frame, but in this case it will add 30, so and the total size will be 1548. Alright, so what will happen? Fragmentation. switch port has to fragment. This frame has to fragment so that it can pass through the port. So it will slow down the process. But when it comes to .1Q, it is perfectly fine. It is within the limit. 1518 plus 4 equal to 1522, which is allowed. Okay, so .1Q is better. ISL will encapsulate every frame, whether it is tagged with VLAN 1 or not. Sorry, not VLAN 1, but native VLAN. So if the frame is tagged with native VLAN, ISL will not spare it, it will still encapsulate, but .1Q will give exception to native VLAN. That's the main difference. Alright, so I'll take it to switch. I'll configure two VLANs here. VLAN let's say 77 and 88. Let's make it one more, 99. Okay, I'll move this port into VLAN 77 and this one in 77 as well. Okay, and then we'll do connectivity check. Alright, so this router's IP is 10.1.1.1. Router 4 is 10.1.1.4. Okay, this is the scene. These two ports and these two ports will be .1Q trunk. Okay, 802.1Q trunk. While these two ports, these two links, not port, because actually ports are same on both ends. That is why I mentioned in the middle it will be ISL. First thing was creation of VLAN. Second is access port configuration, like this one and this one. Third is trunk, but in trunks we'll use .1Q here and here, and we'll use ISL here. Okay, so let me clean it. First I'll start with VLAN creation. I'll go to switch 2, switch 1, 77 88 99, config T, CONF1G, VLAN 77 88 99. Okay, I should have mentioned some space here. This laptop is pretty new to me. Alright, done. You can just copy and paste on switch 2, config T, terminal, paste, enter. Switch 3, okay, so VLANs are created. How would you verify it? Show VLAN brief. It will give you the list of all the VLANs which are present. See. Okay, point number 1 is done. This one is done, VLAN creation. Now I'll configure access port. 0/2. It will be VLAN 77 here, and it will be VLAN 77 here. Okay, 0/2 of switch 2. 0/2 of switch 2. Command is very simple. Switch port mode access. We are tagging it with a single VLAN. Switch port access VLAN 77. No shutdown. Enter. This one is done. Now we'll go to switch number 3, 0/4. Switch port mode access. Switch port access VLAN 77. No shut. You can verify the configuration of the port with show run interface FA0/4. Show run interface FA0/4. See what you configured. It is done. So access port configuration is done. Now these two links will be .1q, these two will be .1q, and these two will be ISL. Okay, let me start with switch number 2. Switch number 2 has 4 ports, 10, 12, these two and these two. Okay, all will be in .1q, and remember that both ends need to be same. You can't have ISL at one end and .1q at other. 10, 12, 16, 18. Switch number 2. Config T, interface range 0/10, 0/12, FA0/16, FA0/18. Okay, we need to make it .1q. Switch port, trunk, encapsulation .1q. Switch port, mode, trunk. This is the second command. Now main command is no shutdown. Okay, switch 2 is configured with trunk. I'll go to switch 1 now. These two interfaces will be .1q, 10 and 12. Switch port, trunk, encapsulation .1q. Okay, switch port, mode, trunk. Why I'm writing complete command? So that you can see, because this is something new. No shutdown. I'll also show you how to verify a trunk. It is done on switch 1 for these two. Now I'll do configuration on switch 1 for these two, 13 and 15, but ISL. Config T, interface range FA0/13, FA0/15. Switch port, trunk, encapsulation ISL. Interswitch link. ISL is interswitch link. Switch port, mode, trunk. Most important, no shut. Switch 1 is also done. Now we'll go to switch 3 and 13 and 15 ISL. These copy because same interfaces. Paste. Switch port, trunk, encapsulation ISL. Switch port, mode, trunk. No shutdown. Done. Now these two ports, 16 and 18, .1q. Switch port, trunk, encapsulation .1q. You can't have a different switch port, mode, trunk. Done. So we have done everything now. I mean trunk part. How would you verify trunk? Show interface trunk. You can see that trunking is done. Status is trunking. Switch 3 two ports are in ISL and these two are in .1q. This is static. If it was dynamically formed or negotiated, then you would see N-802 and -ISL. Okay, I'll show that to you in a couple of lectures away. This is the native VLAN. You can see these VLANs are allowed to travel. So whenever traffic will pass for VLAN, let's say 77 or 99, it will be allowed. The same thing should be at other end. This is by default. I'll also tell you how to edit it. Okay, so I think we are done. Now I'll try to ping from R1 to R4. R1's IP is 10.1.1.1. It is R4 is 10.1.1.4. So everything is normal. Then we should be able to ping. Have we set up the IPs? Let's verify first. I don't think I've set up. Or have I? I've set up. Not an issue. 10.1.1.4. If everything is alright, we should be able to ping. See, wonderful. It is pinging. First packet is lost due to ARP generation. Okay, address resolution protocol. It is now working. Alright. So these were in Vlan 77, right? So what I can do, I can create interface Vlan 88 here on switch 1 and interface Vlan 88 on switch 2. I'll give IPs like 20.1.1.1 here and 22 here. These will also ping because trunk is permitting that, right? Let me show that to you very quickly, because this Vlan 88 is existing here, right? Config T interface Vlan 88 IP address 20.1.1.1 255.255.255.0 no shut. Switch 1 is configured and now switch 2. If trunk is working well, we should be able to see the ping as well. Interface Vlan 88 IP address 20.1.1.2 255.255.255.0 no shut. So let's check the status of interface brief. Vlan 88 should be up because it is up and up. Let me try to ping 20.1.1.1, which is switch 1. See, it is pinging. It means trunk is permitting the traffic. Show interface trunk. You can check. See, these VLANs are allowed. Okay, this is how you can configure access port, trunk port. Okay, if you want to check the status of one particular port, there is one more way. Show interface, let's say FA0/10, then space switch port. It will tell you whether the port is routed port or access port or trunk port. If trunk, then with which encapsulation. You can see which one, 0/10, right? It is enabled, it is trunk, it is encapsulating .1q. This is the .1q is an encapsulation. Default access mode is 1 by default. So this is how you can check everything. Fine friends, so I've taken much of your time. I hope you've learned about access, trunk, very easy things, and you will be comfortable in future. So do give me appropriate rating and feedback once you are done with this lecture. I hope it's been informative to you. Thank you so much.